Okay, this is the last section of this unit, and it takes the time, and we're just going to do a little bit with it here, to look at another type of probability distribution called Poisson's. Okay, Poisson's probability distribution. Now, in this is the distribution often used for describing behavior of rare events with very small probabilities. And they use radioactive decay, arrival of people in a line. Again, they're going to talk about death rates. I mean, some things, some different kind of scenarios than maybe what we're used to. Okay. Now, so the number of occurrences of an event, okay, over some specific interval, and the intervals can be time, distance, area, volume, or some similar unit. Most of the ones that we're going to talk about here are just going to be on time. Okay, they're going to talk about time. Now, some of the requirements of a Poisson distribution, they're very similar to what we did with binomial, okay? But because of the type of situation we're dealing with, you can see the formula that's given up there is quite different, okay? The requirement says the random variable x is the number of occurrences of an event over some interval. Occurrences must be random, they must be independent, and they must be uniformly distributed over that interval. They have to be smooth and no up and down, kind of action going on. And notice what that formula says. Okay, it says the probability of x equals mu raised to the x power times e raised to the negative mu power over x factorial. Okay, that's messy. All that can be done on a calculator, but nicely enough, under the distributions tab, we also have Poissons there. We're going to use that calculator button, that feature, to find these. They're not going to ask you any problems on checking the requirements of a Poisson distribution. All of these are going to be Poisson distributions. What we need to be able to do is be able to find the probability in each one of these instances. Okay, so that's all we're going to be asked to do. So on the next page, on the top of the page, I'm going to show you how to do these on your calculator. Okay, so on 1 through 4, it says assume that the Poisson distribution applies and proceed to use the given mean to find the indicated probability. Okay, so again, on your calculator, move it to the side over here. Okay. Okay, so here are my list of distributions. Okay, I'm going to go down. We had the binomes right here. Immediately following are Poissons. Okay, so there's 2 of them there. We want that first one, Poisson PDF. So I'm going to press that. Okay, now that first feature there is actually like, it's supposed to be mu, um, but they've identified it differently here. So I'm going to put in 1 divided by 6, and for the value of x is going to be what's inside the parentheses. So in this case, it's 0. Okay. So if the mean is 1/6 and the x value is 0, okay, that means that I get a probability of, we want to go 3 decimal places again, just like we had before. Okay, we get a probability of 0.846. Okay, and that's it. That's all you've got to do. Okay. So they just give you the information straight out on 1 through 4. What we've got to do is find the information a little bit more clearly on 5, 6, and 7. And that's where I'm going to let you stop. I gave you another page of problems. I've changed my mind on those. This will be all the practice you need. There's only going to be like 1 or 2 questions on the test, which is our next sheet here. So I think you'll be okay with this amount of practice. Okay. So on number 7 on the bottom of the page, okay, number 7, move it up just a little bit more. Okay. Number 7 says radioactive atoms are unstable because they have too much energy. When they release their extra energy, they are said to decay. When studying cesium 137, a nuclear engineer found that over 365 days, 1 million radioactive atoms decayed to 977,287. Find the number of radioactive items that decayed in a day. So the first thing I will need to do, okay, is I need to subtract 1,000,000 and the 977,000. So when I take those values and subtract, I get over the course of those 365 days, I know that 22,713 decayed. But it doesn't want to know what was the total for 360. It wants to know how much decayed in one day. It does the same thing here. It does the same thing on number 5. So you need to know how much are we looking at over that time interval to convert it to like a daily amount. When I divide by 365, I get 62.2, and that is your mean. That is your mean. Now, in this case, I'm trying to find if x equals 50, then what's the probability, okay, that occurs? Well, again, now that I've got those two numbers, I'm going to go to the calculator. So I'm going to clear that. Go second, vars. I'm going to arrow down to Poisson PDF. I'm going to plug in 62.2, and I'm going to plug in 50 as my x value. Paste that into the formula, and I get a probability of 0.0156. And depending upon what number you use, okay, as your mean, it might round to 0.015. I'll be a little bit lenient with those values, okay? So just be careful when you plug that back in and how you write that down. But what I was looking for with this probability was 3 significant digits. In this example, the 0 isn't considered significant, so the 1, 5, and 6 are. So that's why I went to those decimal places. Okay, and like I said, the other problems will be very much like this. The calculator is a huge help, so you don't have to mess with the formula. It'll do all the work for you. So if something doesn't look right, okay, give me a holler, but send me a note. But otherwise, I think you'll be okay. Now, from here on, the next step is to go ahead and complete that test form B that I gave you. Okay, and again, I'm not looking for that until like next week. So you've got time to be able to finish not only these extra lessons here, but also get into that test, and even the week after if need be. Okay, so we have one more chapter of like 4 units to cover. I plan on putting those up um, probably next week, and then you can get to those um, as need be, however whatever's appropriate for you guys. But again, um, I'll kind of put some tentative guidelines and deadlines up for you to go by, but I'm not going to mess with a final. That chapter 5 test will be your final test, and then that should pretty much fulfill the requirements of what you need for this class. Okay, so just I'll keep in touch with some other stuff here, but anything you're struggling on, give me a holler, and I'll help you kind of wrap it up so we can kind of keep moving. But I'll finish up what I want to get done for the next chapter and get those into your packets here probably next week. Okay, thanks.